Okay, welcome to today's lesson. In this video, we're going to look at projectile motion. Projectile motion. So what's a projectile motion? A projectile motion is one that follows a curved or parabolic path. And this curved or parabolic path is also known as the trajectory path, right? So any motion that follows a curved or parabolic path is known as a projectile motion. So if you take, for instance, when this guy kicks this ball, the ball moves in a curved path or in a parabolic path, right? So any motion that follows this curved path or this parabolic path or this path that is called the trajectory path is called the projectile motion, right? So this curved path, this motion is due to two independent motion. It is due to a horizontal motion and it is due to a vertical motion, right? So in a projectile motion, there are two independent motion. We have the horizontal motion and the vertical motion. So the horizontal motion is what is responsible for the horizontal movement of the body, while the vertical motion involves the vertical movement of the body, right? And there is a velocity that drives this motion. So the velocity that drives the horizontal motion is the horizontal velocity, and it is given as Vs is equal to u cos what? Cos theta, where your u is the speed at which the projectile is projected, while the theta is the angle of what? Projection. Then the velocity that is responsible for the vertical movement of the body is your vertical velocity, and it is given as Vy. And the formula is what? U sine theta minus what? Gt. It is minus because it is moving against gravity. So your G is your acceleration due to gravity, T is the time taken, your theta is the angle of projection, while your U is the velocity at which the object is projected, right? So again, a projectile motion is a type of motion that follows a curved or parabolic path, which is also called the trajectory path. And this motion is due to two independent motion, the horizontal motion and the vertical motion. The velocity that drives the horizontal motion is called the horizontal velocity, and it is given as Vx is equal to u cos theta, while the velocity that drives the vertical motion is the vertical velocity, and it is given as Vy is equal to u sine theta minus gt, right? So having known this, let's dash to the terms used in projectile motion. Basically, there are three terms that are used in describing a projectile motion. We have the time of flight, the maximum height, and the range, right? So first off, we have the time of flight. And the time of flight is simply the time required for a projectile to return to the same plane from which it was projected. So if we take, for instance, this projectile motion, as the guy kicks this ball, this is the point of projection, right? As the guy kicks this ball, the ball travels through that curved path and then lands on the projection plane. This is the projection plane, right? So the time it takes for this object to return to the same plane from which it was projected is called the time of flight, right? The time taken for the projectile to travel and then hit the projection plane is called the time of flight. And the formula is given as t, which is the time of flight, is equal to 2u sine theta all over g, where your g is your acceleration due to gravity, your u is the velocity at which the object is projected, right? While your theta is the angle of what? Is the angle of projection. Then we have maximum height, right? And maximum height is the highest distance traveled on the vertical plane. So this is the vertical plane. The highest distance that is traveled on the vertical plane, or the highest distance that is reached by the projectile, is known as the maximum height, right? And the formula is given as maximum height h is equal to u squared sine squared theta over 2g, right? Then we have range. Range is the total horizontal distance moved from the point of projection to the point where the projectile hits the projection plane, right? So range is the total horizontal distance that is moved from the point of projection to where the projectile hits the projection plane. So this horizontal distance from here to here is called the range, right? And the formula for range is u squared sine 2 theta over g, right? So it's very important to know that range is maximum when the angle of projection theta is equal to 45 degrees, right? This is a very important exam question. Range is maximum. It is maximum. It is maximum when the angle of projection theta is equal to 45 degrees, right? So it's very important that you know the different formulas that we use for the time of flight, for maximum height and range, right? So having known this, let's look at the first question that we have here. A particle is projected with a speed of 20 meters per second at an angle of elevation of 60 degrees. Find its greatest height. B, the range on the horizontal plane through the point of projection. C, the total time of flight. And D, the velocity in magnitude in the direction after 0.75 seconds. Right? So the first thing I would want to do here is to first of all feature the parameters that are given in this question. So again, the question is a particle is projected with a speed of 20 meters per second, right? So the speed of projection is what? 20 meters per second at an angle of elevation of 60 degrees. So theta is equal to what? 60 degrees. Find its greatest height. So from the question, you already know that this is a projectile motion. So if I draw a pictorial representation of this motion, I would have something like this. The object is projected with a velocity of what? 20 meters per second at an angle of elevation of what? 60 degrees. We are asked to find its greatest height. So the first thing that we're looking for here is what? The maximum height. That's the greatest height, right? So here we're looking for the maximum height, and the formula is h, which is maximum height, is equal to u squared sine square theta over what? Over 2g, right? So the value of our u is what? 20 meters per second, right? So that is 20 squared, since we have u squared here, sine squared, what's the value of theta? Is 60 divided by 2 times what? Your g is what? Acceleration due to gravity, and the value is what? 9.8, right? So g is equal to what? 9.8 meters per second squared. Okay, so having done that, this will now be equal to 20 squared is 20 times 20, and that will give you 400, right? Sine 60 would give us 0.866, right? So that would be times 0.866 squared, right? Sine 60, that is equal to what? 0.866, right? So since we have sine square 60, that will be 0.866 squared, right? Divided by 2 times 9.8 will give us 19 point what? 0.6, right? So having done that, this will be equal to 400 times, so 0.866 raised to the power of 2, so raised to the power of 2, that will be equal to 0.75, right? So times 0.75 divided by what? 19.6. So 400 times 0.75, 0.75 times 400, that will be equal to 300. So that will be equal to 300 divided by 19.6. So 300 divided by 19.6 divided by 19.6, that will be equal to 15.3. 15.3. So this is our greatest height, which is the maximum height. Maximum height is equal to 15.3 meters. This is our answer for the first question. Then the next question that we have here is to find the range on the horizontal plane through the point of projection. Is to look for the range, right? So our B is to look for the range. So range is equal to what? U squared sine 2 theta over what? Over G. So my U squared is what? 20 squared. My U is what? 20, right? So that will be 20 squared sine 2, open bracket, what? My theta is what? 60, right? Divided by what? My G is 9.8. So 20 times 20, that will give me what? 20 times 20 will give me 400 sine 2 times 60 will give me 120 divided by what? 9.8. So this will be equal to, that will now be equal to 400 sine 120 sine 120 is equal to 0.866, right? So that's times 0.866 divided by what? 9.8, right? So 400 times 0.866 equal to, divided by 9.8, that will be equal to 35.35, right? That will be equal to 35.35 meters, right? So my range is what? 35.35. So my range is what? 35.35 meters. So the range, like I said, is the total horizontal distance from the point of projection to where the projectile hits the projection plane. So our range, we have calculated it to be what? 35.35 what? Meters. And the maximum height we've calculated to be what? 15.3 what? Meters. So having done that, the next thing that we're going to look for is the time of flight, right? We have to look for the time of what? Of flight. So the formula for time of flight is equal to what? 2u sine theta over what? Over g. So this will be equal to 2 times, my u is what? 20 sine what? 60 divided by what? 9.8. So this will be equal to 40. 2 times 20 will give me 40 times sine 60 will give me 0.866, right? Divided by what? 9.8. So if I bring out my calculator, when I punch that, 40 times 0.866, that will be equal to, divided by 9.8, that will be equal to, 3.5, right? So therefore, my time of flight is equal to what? 3.5 seconds, right? So this is my time of flight. This is the time it will take the projectile from the point of projection back to where? The projection plane. That is the time it will take this projectile to travel from here down and hit what? The projection plane. That's the time of light, right? So the next thing that we're looking for is the velocity, magnitude, and the direction after 0.75 seconds. the velocity in magnitude and direction after 0.75 seconds. So the velocity in magnitude and direction, we are simply referring to the resultant velocity, the velocity in magnitude and direction after 0.75 seconds. If you remember from the very first page, I said that there are two velocities that are responsible for a projectile motion, right? There is a horizontal velocity, which is given as u cos theta, and there is a vertical velocity, which is given as u sin theta minus what? Gt. So the horizontal velocity is what is responsible for the horizontal movement of the body, right? While the vertical velocity is what is responsible for the vertical movement of the body, for the upward movement of the body, right? So since we are looking for the velocity, magnitude, and direction after 0.75 seconds, we would consider these two velocities, the horizontal velocity and the vertical velocity, right? So here we'll solve D here. So first of all, we should know that the horizontal velocity is given as what? U cos what? Cos theta. So this will be equal to, my U is 20, cos what? My theta is what? 60. So this will be equal to 20 times cos 60 is 0.5, right? So 20 times 0.5, that will give me 10. So my horizontal velocity is what? 10 meters per second. Then I will also look for the vertical velocity Vy, and it is given as u sine theta minus what? Gt, right? So that will be equal to, my u is what? 20 sine, my theta is what? 60 minus 9.8, which is the value of g, times what? 0.75, which is the time, right? 0.75 seconds. That is the time that is given. So having done that, this will be equal to 20 sine 60 is what? Sine 60 is equal to 0.866, right? So times 0.866 minus 9.8 times 0.75, 9.8 times 0.75, that will give us 7.35, right? Minus 7.35. So 20 times 0.866 will be equal to 20 times 0.866. That will be equal to 17.32. 17.32 minus 7.35. That will be equal to what? Minus 7.35. That will be equal to 9.97. 9.97 meters per second. So this is the vertical velocity, and this is what? The horizontal velocity. But what we have to look for is the velocity, magnitude, and direction after 0.75 seconds, right? So if I represent this better, there is a horizontal velocity and there is what? A vertical velocity, right? So the horizontal velocity, which is Vx, is what? 10 meters per second. And the vertical velocity is what? Which is Vy, is what? 9.97 meters per second, right? So the velocity in magnitude is the resultant velocity. What we are asked to look for here is the resultant velocity, which I would represent as what? VR, right? So my VR, which is my resultant velocity, will be equal to the square root of Vx squared plus what? Vy squared, right? So that will be equal to the square root of 10 squared, which is my Vx, is given as 10 meters per second, and my Vy, which is my vertical velocity, I've calculated it to be 9.97, right? Plus what? 9.97 squared, right? So this will be equal to 10 squared is what? 100 plus 9.97 squared. What would that be? So 9.97 raised to the power of 2, that will give me 99.4009. 99.4009 square root. So if I add this up, that will be equal to 199.4009, right? So the square root of 199.4009, square root of 199.4009, that will be equal to 14, right? 14.1. That will be equal to 14.12 meters per second. So this is my what? This is my velocity in magnitude after 0.75 seconds, right? Right? So the next thing that we are asked to look for is the direction. At what angle? So we are asked to calculate what? The direction. And how do we go about that? So since we have this representation already, my theta would be here, right? My theta will be here. So you should know that tan theta is equal to opposite over what? Adjacent. So from this, we have our opposite, which is the side facing this theta, to be what? Vy, which is what? 9.97, right? So my opposite is what? My vertical velocity over what? My adjacent. My adjacent in this question is what? My horizontal velocity, Vx, right? So the vertical velocity, we had it to be 9.97, and the horizontal velocity, we had it to be what? To be 10 meters per second, right? So 9.97 divided by 10, 9.97 divided by 10 will be equal to 0.997, right? So my tan theta is equal to what? 0.997. So what I will do here is to look for theta, right? So how do I look for theta? My theta will now be equal to the tan inverse of what? Of 0.997. So how do we look for the tan inverse of 0.997? What I will do is to press shift, press tan. The first thing I will do is what? I'll press shift and then I'll press tan and then impute my value, which is what? 0.997, right? So that will be equal to 44.9, right? So my theta is equal to 44.9, and this is approximately 45 degrees, right? So this is our answer to this question. Very simple and straightforward, right? So just a quick recap. A projectile motion is a motion that follows a curved or parabolic path, and this is the curved or parabolic path, right? If you shoot a catapult, you throw something from a cliff, it will always follow this parabolic path, this curved path, or this trajectory path. So any motion that follows this path is known as a projectile motion. And there are two independent motions that are responsible for a projectile motion. There is a horizontal motion and a vertical motion. And there is a velocity that drives this motion. The one that drives the horizontal motion is a horizontal velocity, and it is given as u cos theta. The one that drives the vertical motion is the vertical velocity, and it is given as u sine theta minus gt. It is minus because the body is moving against gravity, is moving upward, right? And we looked at the terms used in describing a projectile motion: time of flight, maximum height, and the range. Formula for time of flight is t is equal to 2u sine theta over g. Maximum height is u squared sine squared theta over 2g, and then range is u squared sine 2 theta over g. And I said that range is maximum when theta is equal to what? 45 degrees.